Hello, I have a question in 3.1. It's about functions, finding the domain. And for those who are kind of sketchy on what is the domain are the values of x that make the function defined. And that's kind of a formal way of saying it, but kind of a more, less informal. It's also known as the allowable values of x. So in other words, it's what can be put into the function and get an output. Because as you recall, a function is one thing in and one thing out. So if a number you put something in and nothing happens, it doesn't give you an output because something is not allowed, then that number would not be allowed to be within the machine. It's kind of like a Coke machine when you put your dollar in and and you hit a button and a soda pop comes out. Well, the dollar that you put in was allowed because it gave you an output. But on the other end of the stick, if you put a rock or pebble inside the Coke machine or some kind of a piece of paper that the machine doesn't even accept, then it wouldn't give you a soda. So whatever you put in, like a rock or a pebble, would not fit in that domain. So same thing in math. Some machines, which we call these mathematical machines if you want to. I mean, that's a good term as any for what a function is. It's just a mathematical machine, one thing in, one thing out. And so these are like three different machines I have it on here, and I'm wanting to know what the domain of this function is. Now, sometimes it's quite difficult, and sometimes it's quite easy finding the domain. But I kind of look at it this way: if the machine will take anything, okay, then it's all real numbers. So you kind of try to be more or less an optimist sometimes and a pessimist other times. And what I mean by that, optimist would be someone who assumes everything is going to work and then discard everything else out. A pessimist is assuming nothing works and try to figure out all the numbers that don't work. Sometimes one's better than the other. Now on this one, f of x equals x squared minus 3x plus 1, if you try to figure out what numbers don't work, you're going to be there for a long time because you can't find any. Because if you put a number in this machine, square it, minus 3 times the number plus 4, it always gives you an output. It may be not what you're looking for, but it will give you an output. So for example, if you put 0 in here, it'd be 0 squared minus 3 times 0 plus 4, and the output would be 4. And so you put 0 in, 4 comes out. That's what you call evaluating a machine, or evaluating a function. And so if you put in 1 squared, negative 3 times 1 plus 4, I think it turns out to be like 6 or something like that. But when you put 1 in, 1 comes in, 6 comes out. So that works as well. So there's no number that you put in there that won't work. That's double negative, which means everything's going to work. So in this first example, the domain is all real numbers, or just simply this. A lot of people ask me, which notation do you prefer? Well, if you're in my online class, they're probably going to want to write like this. If you're in my traditional classes, this is fine or this is fine. So in my math lab, it's very, very picky of how they want you to write the answer, the format. And as probably most of you guys have already figured that out. And but my traditional classes, I'll take either one. But my math lab, they're going to probably want the top one. So now, example 2. Now, this one here is be better if I just kind of found out what numbers won't work. Now, there's a couple of things that people see that they say, well, they think about 0, because whenever they see a fraction, they know something about 0 and they don't know which one it goes with. So, for example, if I put a negative 2 in this machine, negative 2. So, negative 2 plus 2 is 0. And then negative 2 times negative is negative 4, minus 1 is negative 5. So you get 0 divided by negative 5. And here's where people get, okay, which one is it? Which one is it? Well, 0 divided by negative 5 happens to be 0 because you can divide 0 in that many parts. So negative 2 happens to be a good number. But when you have fractions, you cannot divide by 0. And that's something I'm sure you've heard of. So if you have 2x minus 1, set the denominator equal to 0, that will tell you when the denominator equals 0. And what you do is once you figure out what number that is, you exclude that number and everything else works. So add 1 divided by 2, this would be x equals 1/2. Now this is where people fall in the trap and say, okay, x equals 1/2, that's my answer. That means that's the domain. On the contrary, that's the one number that doesn't work. So everything else does work. So this is kind of the pessimistic, how you try to figure out what doesn't work. So 1/2 doesn't work. So you take the 1/2 out, and it's everything else. Now here's the trick. How do you write that down? Well, there's a couple of ways. You can kind of write an interval notation. So this one starts on the left arrow and goes to the right arrow, negative infinity to infinity. But on this one, it starts on the left arrow, goes to 1/2, exclude that one, chop that number out, and then go from 1/2 to infinity. So in interval notation, it kind of looks like this, but it's two intervals. Negative infinity to negative 1/2, union, it's actually positive 1/2, and in union, 1/2 to infinity. So it's everything except for 1/2. Now that would be kind of what the online students would need to write on the MyMathLab. Kind of depends on how they say it. So that's why MyMathLab is very picky about that sort of thing. And but everybody else, you can do it this way, or you can say all real numbers. Well, it's not all real numbers. It's all real numbers except for 1/2. So what we'll do is take out the number 1/2. So here's where my online students are very, very jealous, because they probably cannot write it this way. So, because MyMathLab won't take that. So, but anyway, it's negative infinity to 1/2, and then union 1/2 to infinity. And all real numbers except 1/2. Now you can't just say 1/2. You can't just say x equals 1/2 in a circle and say that's my domain. As a matter of fact, you can't be more wrong. Okay, you're saying 1/2 works if you're saying that's in the domain, and 1/2 is the only number that doesn't work. So you got to be careful with that kind of notation. This exercise 3 is a square root. F of x equals the square root of negative 3x plus 6. And as we know, that's about square roots, it only accept non-negative numbers. And what I mean by non-negative is positive or 0. So when you have square roots, you have to be careful and set the radicand greater than or equal to 0. So this is kind of the optimist. Oh, what numbers will work? What numbers will work? Well, so the radicand has to be greater than or equal to 0. Now, what's the radicand? Radicand is the number inside the radical. So in other words, the negative 3x plus 6 is greater than or equal to 0. So this is more an optimist. So we're going to figure out what numbers do work. So you solve this, and it should look somewhat familiar to you. If you ignore everything else here, this is a problem out of like 1.5. That's why we solved those inequalities back in 1.5 when we got to that point, or is it 1.6? I can't remember for sure, but it was either 1.5, 1.6 when we solved the inequalities. Actually, I think it was 1.5. And we are solving those, and that was the point, because we were at some point going to get to this type of a problem when we're finding domain of functions. And so that's why, so we didn't do this back in 1.5. Now, then we'd have to teach you how to do this right now. But now we already know how to solve this. So you move the 6 over, so for negative 3x is greater than or equal to negative 6, divide by negative 3, and then remember you have to switch the inequality symbol around, so it's less than or equal to, and negative 6 divided by negative 3 is a positive 2. And that means it's all real numbers that are less than or equal to 2. That means 2 or less. Left side of 2. I mean, all those are synonyms. Left side of 2 equal to 2, less than or equal to 2. So no number bigger than 2, so it's kind of a double negative, but anyway, those all the numbers on the left side of 2. So it looks like an interval notation, negative infinity to 2. And think about it, it should be able to be a parentheses or a bracket, and it should be a bracket, because bracket means it includes it. So it's negative infinity to 2 with a bracket on the 2, but not on the infinity symbol. So some people has learned the set builder notation. The set builder looks like this: set the x such that x is less than or equal to 2. It's just not one of my favorite. And the thing about it is, MyMathLab uses this quite a bit in there. It's not one of my favorites though, but it's x such that x is less than or equal to 2. So my preference here is the negative infinity up to 2 with a bracket. So, but anyway, here is finding the domain. Now, I understand domain basically means anything acceptable when it's all real numbers. In other words, it will not exclude. It's an all-inclusive function. Takes everything. Okay, so this one here takes everything except for one number, the number 1/2, and then this one is one side of a number or another side of a number. So this one's everything. This one's everything except for one thing. So basically, it's an interval on the left, an interval on the right, and it's not including that specific number. This one right here is an interval that is only on one side of the number. So, and for the most part, that's how the domain kind of works, is looking for that kind of a set of numbers. And anyway, here are 3 examples. Is this all of them? No, but this is, if you know how to do a polynomial or a quadratic equation, I know that's all relevant. Of course, that one's easy. Or fraction, or square root, you're pretty much set. Now, I will say before I close up on this one is, if this one was a cube root, you got to be careful. It's not always radical and greater than or equal to 0. It's only for square roots and fourth roots and sixth roots. If you have an odd root, if this was a cube root in here, then it would be all real numbers. So don't just assume that you see a radical, then set the radical greater than or equal to 0, because you can only take square roots of positive numbers. But cube roots don't work that way. You can do cube roots of positives and negatives. So anyway, that's it on this one.